talked about doing it. But in UI view, it's actually slightly more likely that you might want to have an initializer. So it's a slightly complicated thing, only slightly, in that UI view has two initializers that you have to deal with. And that's because UI views can be created in two different ways. In code, by just saying UI view and this frame initializer, which is just the frame in the super view coordinate system where this view is going to live. But then there's also this init with coder, and I'm not going to talk about coders and archiving and all that, but that is the initializer that is called when the view comes out of a storyboard. So if you create a view by dragging out in a storyboard, its initializer is this coder thing, okay? So if you absolutely have to use an initializer to initialize something in your UI view, you're going to want to implement both of these things. And I recommend this kind of format here, where you override init with frame there. That is a designated initializer in UI view. And then there's actually a required initializer, which is the decoder one. So if you implement the init with frame, you have to implement the coder ones required. Because then as soon as you implement the init with frame, you'll no longer inherit all of your designated initializers. You won't inherit the init with the coder. So basically implement them both and then just factor out your initialization code into some setup method or something and call that. Okay? So that's only if you absolutely have to have an initializer. All right, there's another alternative to initializing, which is if you can wait until the initialization is finished, but you want something really early in the view's life, you can implement this method awake from nib. But that only works for views that come out of a storyboard. Okay? Awake from nib means I just awoke from coming out of a storyboard. So now you can initialize me. So it's a little bit limited because it only is good for views that come out of a storyboard, but it is an alternative. Now, okay, so that's all I want to say about that actually. All right, so let's go on to how do we draw and handle events in this rectangular area? Well, we need a coordinate system to work in. So there's some data structures I'm going to show you real quick to get us started here that we're going to use when we're drawing and handling events. First of all coordinates are going to be CG floats. Okay, CG floats is a type in Swift struct, and always use CG float when you're drawing or handling events in a view. Do not use double, do not use float. If you use those in your homework, you're going to get dinged, okay? CG float. Now, doubles and floats can be converted to a CG float using the initializer. CG float has initializers for floats and doubles that you can pass and turn it into a float. But you always want things to be CG floats when you're working in the coordinate system, okay? Now, there's a couple other structs that are important here. One is CG point. It's just two floats, x and y. It just defines a point in the coordinate system. Couldn't be simpler, okay? And there's also CG size. Just defines a width and a height in the coordinate system, okay? So these are just simple structs. That's all they are, structs. I don't know, certainly point I don't think has any other methods on it or anything. Size, maybe, I don't think so though. But these two are combined, the points and the size, to CG rect. So a CG rect is a struct that has a point and a size. The point is the origin of the rect, upper left, which I'm going to talk about in a second. And then the size is the width and height. Now rect has a lot of methods on it. Okay, rect has things like min x, which is the left edge of the rect, or mid y, which is the midpoint of the rectangle vertically, or intersects, and you pass it another rect, and it'll tell you Boolean whether it intersects that rect, right? The two rects overlap. Or intersect, which says take this other rect and create a smaller rectangle, which is the intersection of those two rects. Or contains point, okay? Where you pass it a point, and it'll tell you whether it contains that point. So rect, it's a struct, but it has a lot of cool methods in there. There's a whole bunch more. You can just type a rect type and then a dot, and let Xcode show you all the cool methods it has, okay? All right, so those are the kind of data types we're going to use to talk about our coordinate system and to write our code in our coordinate system. So let's talk about the view's coordinate system itself. First of all, origin upper left. Some of you might be used to origin lower left, like Cartesian coordinates, the origin is in the lower left. But all the origin that you use in a view is in the upper left. So that means increasing y is down the screen. Increasing x is across. So I put an example 500, 500,35 over there. It's 500 across and only 35 down, okay, from the upper left. The units that we're talking about here are points, not pixels. Okay? Very high resolution displays have more than 1 pixel per point. Okay? Because they're able to draw very fine curves, very fine text, etc. You don't usually care about the difference between points and pixels. It's automatically handled for you because you're doing things like drawing text or drawing an arc, and the system automatically uses as much pixels as it can to make things nice. But occasionally you do care because maybe you're drawing something very finely detailed and you want to control on pixel boundaries. And if you want to do that, you can get this property in View called content scale factor, and it will return the number of pixels per point. So on a Retina display, that's going to be 2. On a non-Retina display, that will be 1. It could be anything, though. Okay? So you shouldn't write your code assuming it's 2 or 1. You should just write your code, get the content scale factor, and you'll know how many pixels per point. Okay? 99% of the time, you don't have to worry about this, but in your assignment 3, hint, hint, you might have to. Okay? So what about the boundaries of where drawing happens? You've got this rectangular area. Well, there's a very important property called bounds, which is a CG rect, which describes the area you're drawing in your own coordinate system. Okay? It's important that it's in your own coordinate system because these views can be scaled and even rotated and translated to other coordinate systems, but when you're using the bounds and you're drawing yourself, you have this rectangle, you know where it is. Now, the origin of your bounds usually is 0, 0, but you could define it to mean something else. For example, scroll views, they define their origin to be where they are in the thing they're scrolling. That's just what they define origin to be. But 90% of the time, your origin is just going to be 0, 0. And so the width and height is what you're going to care about. How big a space am I drawing into? There are 2 other properties that often get confused with bounds, but don't let this happen to you. One is center. Center is the center of your view rectangle in your super view's coordinate system, not in yours. So if you write code that says, oh, I want to start drawing something in the middle of my rectangle, I'll get center. That's wrong. Okay? Center is in your super views. Center positions you. It has nothing to do with how you draw. It just says where you are in your super view. Same thing, frame. Frame is a rectangle in your super view's coordinate system that contains you. Okay? It contains all of you, of your drawing. But it's in your super view's coordinate system, so it's only good to position you, not for drawing. When you're drawing, you use bounds. To kind of give you a picture of this, it's better. Like you might think that the frame size is exactly the same as the bound size. Right? If it's a rectangle that contains my rectangle, it must be exactly the same size. But no, because views can be rotated. Okay? And if you rotate your view like this green view, look how much bigger the frame is. The rectangle that contains you is much bigger than you because you're tilted, right? Make sense? So don't confuse frame and center, which are about positioning, with bounds, which is your size, the area that you're drawing into in your own coordinate system. Okay? Okay, so creating views. How do we create views? Most often, views are created by dragging them out into your storyboard. Okay? That's 95% of the time. But of course, your views aren't sitting in the object palette. There's buttons and sliders, but there's no your view. So you have to drag out a generic view. It's kind of at the bottom of the palette. You just drag it out. Once you drag it out, though, you have to go to the identity inspector and change the class of that view you dragged out so that it's your class. Okay? So it's a 2-step process. You drag your custom view out, then you change this class to be whatever your custom class is. On rare occasion, you might create an instance of your view in code. Probably never in this class, maybe in your final project, although I doubt it. You just do that using UI views frame initializer, right? So you just say view equals UI view frame. You can even do UI view with no arguments. It'll give you a CG rect 0, which is a frame 0 size and width, and then you could later set its frame to position the view. So here's an example of creating a view in code. I'm going to use UI label. A UI label is a subclass of UI view, so I can send it UI label parentheses frame. So I just give it this frame, which is kind of in the upper left. Notice I've created this view, but it's not on screen yet. Okay? Assuming this code here is in a view controller, I could then say view.addSubview, because remember, view is a property in my view controller, which is that top level view. And I could say add subview of the label, and boom, it'll appear on screen. Okay, at 2020 width 100, height 50. Okay? So it is possible to create views in code. We almost never do that in iOS. We use storyboards. Okay, so when do I want to create my own UI view, right? Well, when don't you want to? Well, you don't want to if you want a button or a slider or anything where there's already an iOS view. But if you want to do something that those things can't do, draw something special or handle touch events like swipes and taps and pinches differently or for a different purpose than those things, then you create your own custom view. So we're going to focus on drawing today, and I'll do gestures in the next lecture. To draw in your UI view, all you need to do is override this method drawRect. Okay? Very simple method, only takes one argument. In the code, it's actually called rect, but I've renamed it to be region that needs to be drawn so that people understand what that argument is. That argument is purely an optimization. It's just the system saying, hey, draw yourself, and really I only care about this rectangle of you. But you can draw the whole self if you want, but this is the only rectangle I really care about. So if you had a view that knew how to draw parts of itself, okay, then it could only draw the part that's in this rectangle. But you can completely ignore this rectangle if you want. It's purely an optimization. Okay? This is very important to understand. You never call drawRect. Ever, never, never. Okay? If you call drawRect in your homework, you're going to be major ding. Because I'm standing here in front of you with red text on my slide saying never. Okay? Do not call drawRect. drawRect is called by the system. Okay? It's called by the system when your view needs to be redrawn. How does the system know your view needs to be redrawn? Because somebody called setNeedsDisplay on your view. And you can call it on yourself if you want. If something has changed about your view, some property or something that would change the way it's drawn, you call setNeedsDisplay on yourself. Eventually, the system will call your drawRect. But it's got to set some things up first. Okay? And there's other views around you that it has to get organized. Okay? So never call drawRect, it's called for you. When you call setNeedsDisplay, you can specify, I really only need this rectangle redisplayed. And then obviously that rectangle is going to show up in the argument to drawRect. Okay? But if multiple people call setNeedsDisplay with different rectangles, probably the union of those rectangles might get called here one time for drawRect. Okay? Make sense? All right. So how do you implement this all-powerful drawRect method? You can use kind of a C-like function-based API called Core Graphics. That's what it's all based on. Or you can use a nice object-oriented thing called UI Bezier Path, which is what we're going to use because we like object-oriented. But since the underlying stuff, Core Graphics, is what UI Bezier Path is built on, I'm going to kind of explain a little bit about the concepts of Core Graphics, how one draws in Core Graphics. The first thing in Core Graphics that's important is you have to get a context to draw in. Okay? So if you're printing, you'll have a printing context. If you're drawing on screen, you'll have a draw on screen context, etc. And inside drawRect, when your drawRect is called by the system, it sets up the drawing context for you. So it's automatically set up, and it's called the current context, the current drawing context. And you can get it if you were using the C API, or C-like API, it's still Swift, but it's functional, function API. You can get it with this function UI graphics get current context. And it'll return this cookie. It's just this magic cookie. You don't know what it is, but it is the context of drawing. Because all of the C-like functional API take a context as an argument. Okay? The Bezier path doesn't do that, no worries. But that one does. So the first thing you need is a context, automatically set up for you when drawRect is called. Then you create paths. You create paths with lines and arcs and things like that. Then you set the drawing attributes, like the colors you want to draw in, the line widths, things like that. And finally, you stroke and fill those paths. Okay? You can do either or both, stroking and filling. So that is fundamentally how you draw. Things like drawing text is just the fonts know how to have the perfect path to draw beautiful letters. And so your stroking would outline the letters, and filling fills in the letters, okay? So even drawing text is just stroking and filling paths, okay? Now, UI Bezier path, this object-oriented thing on top, it always draws in the current context. You don't have to worry about context. It has methods to do things like line 2, arc 2 to build the path. It also has methods for setting a lot of these attributes like line width and things like that. And it has methods to stroke and fill. So it combines all those core graphics things into one class. So let's take a look at UI Bezier path and how we would use it to draw a triangle, let's say. So first we create the path, so we just say UI Bezier path. There are other initializers for UI Bezier path, but you can also just create an empty path, and then you can start moving around. So here I'm going to assume this screen is 160 points wide by 250 wide, and I'm going to draw this triangle here. So I'm going to move to 80, which is halfway across, and 50, which is a little bit down. And then I'm going to add a line down to 140, 150. Then I'm going to add another line over to 10, 150. Then I'm going to close this path. Okay? So that's it. That's how you can make a triangle. Now, I'm kind of lying to you a little bit because as you execute these, nothing is appearing on screen. The screen will be blank. Okay? I was only showing them so you can understand what I was doing there with the lines. So it'll be blank. To make it appear, you have to stroke or fill. So let's set the attributes we want. So I'm going to set the color for filling to be green and the color for stroking to be red. Okay, now notice that I set those with methods on UI color, not with methods on the Bezier path. Okay, that's a little interesting, but that's the way that works. But line width, I do set by talking to the path. So I send a message to the Bezier path to set line width to 3. So once I've set up all my attributes, now I can fill, for example, by saying path fill, and see, I get the rectangle filled in green, or I can say stroke, and it'll stroke the red line. Okay? Pretty straightforward. Most of learning to draw is all about understanding UI Bezier path and all the methods on it. Question back there.
If you had two paths on the screen, then how would you set different colors for those?
If you had two what?
If you had two different shapes on the screen.
Oh yeah, so the question is if I had two shapes on screen, how would I set the colors be different for each one? I would set the colors, stroke or fill one, set the color something else, stroke or fill the other. Okay? Question?
If the path isn't closed, what does fill do?
So the question is, if the path is not closed, what does fill do? Well, it depends on, I think, the winding rule and other things about how that draws, but it will try to fill it in. Okay? I mean, a path could cross back over itself, right? And so filling it might be hard to understand, and so there are rules for that. I'll talk about that just briefly in a second, but it will fill. But there are other things. If you don't close a path, then you can't do things like hit detection, right? Detecting whether a point is inside it because it's not closed, so there is no inside. So you can, UI Bezier path also has kind of pre-canned cool shapes like rounded rect, okay, which is a rectangle that the corners are rounded off of, or obviously ovals and circles. It has ways of doing that. You can also clip to any arbitrary path. So clipping, hopefully everyone knows what that means. That means if I have a path and I say clip, if I say add clip, then all drawing I do after that will only show up if it's inside that path. Okay? So, for example, if you were drawing playing card on screen, playing cards have little rounded rects. So you might draw your playing card in a big rectangle and then clip to a rounded rect so the corners get cut off. Okay? That's a kind of cheap, simple way to get a rounded rect playing card. You can also do hit detection, as I mentioned. The hit detection and the filling depends on the winding rules, and there's this uses even odd fill rule property, which is Boolean yes or no, to say which winding rule it uses. And so people who don't know what that means, don't worry about it. In fact, don't worry about hit detection and any of this stuff because you're not going to have to do this for your homework, but I just want you to know that Bezier path has a lot of other stuff besides just line 2, fill, and stroke. Okay, it has other stuff. You want to look at UI Bezier path, check out its documentation, and kind of experience it in its full glory. Okay, let's talk a little bit more about colors. because I used a color there, that green color. UI color is just an object. It's really powerful. The colors not only can be standard colors like UI color.green color, but you can create a color from RGB, red, green, blue, or HSB, that's hue, saturation, and brightness. You can even set your color to be a pattern so that when you draw with that color, it actually draws some image. Okay, so that's kind of cool. Views have a background color, which you can set on them. Also, colors can be transparent, okay? They can be see-through, partially see-through. This is called alpha. So alpha is a value between 0 and 1. 0 means fully transparent. You can see completely through it. It won't even show up on screen. To 1, which is fully opaque. It obscures anything behind it, anything drawn with this color. And you can create a transparent color from another color with this color with alpha component. This would create kind of half transparent yellow color to draw with, and you can draw in your view with these transparent colors, okay, using these Bezier paths. However, if you draw in your view with transparency, you must tell the system that you are going to do that. And you do that by setting this property on your UI view called opaque to false. And why is this required? Well, because drawing with transparency is expensive, because the views behind you are going to start showing through, okay? So the system has to blend, basically, the different views that are overlapping. That's expensive in terms of graphics power, and so it doesn't want to do that if it doesn't have to, if it can just draw the bits. If you don't set this to false and you try drawing transparently, it's not going to work, okay? Because it's not going to blend with the things behind. You can make your entire view transparent, okay? It has its own property alpha, which you can set to anywhere between 0 and 1. It'll make your view, everything you draw in the view will be however much transparent you want it to be. Okay? What happens when views overlap and enhance transparency? They're blended, as I said. Remember that the subviews order matters. Okay? The thing that's first in the subviews array is in the back, and everything down the right is in front. So when the transparency happens, that's the order it's going to happen in. You can completely hide a view by setting its hidden equal to true. And this is surprisingly common, to just hide a view, and maybe it appears when a certain condition is true on screen or whatever. You can set up this view in your storyboard and then set it hidden to true, and so it comes up, it's not there. And then in code, you say hidden equals false, boom, it appears. Okay, so that's a way to completely hide the view. A hidden view not only doesn't draw, it doesn't receive any touch events either. But it's still in the view hierarchy. It's kind of there waiting, okay? All right, drawing text. So usually you draw text on screen with a UI label. That's what you did with your display, etc. But you might want to draw in your drawRect, and you do that with this class called NSAttributedString, which I'm really not going to cover. You want to look at this documentation if you want to draw text. I'm not going to do a demo of NSAttributedString, but I'm going to give you some code for your assignment next week, and I'm going to use NSAttributedString in the code I'm giving you, so you'll be able to see an example of how it's used. But basically, an attributed string is a bunch of characters and some attributes on those characters. Now, attributed string has a couple of interesting things about it. It's easy to use. You can just create it, pass it a string, and then say draw at point, and that will draw the string with its point, its upper left corner, at that point. And you can even find out how big it's going to be by asking it the size of this attribute string. So it's pretty easy to use in that way. Mutability is not done with var and let for NSAttributed string. There's a different class called NSMutable attributed string. Okay? And why would you want a mutable string, attributed string? Well, because these strings, what makes an attributed string attributed is you can put attributes on the characters in this string. And so a mutable attributed string, you can set the attributes. You can get the string out as an NS string using the string property on NSAttributed string, but NSAttributed string itself is not a string. It's not like a subclass of NS string or anything. It's its own thing. So you set these attributes with functions like setAttributes. It takes a dictionary of attributes. I'll talk to you about what the keys and values are in a second. And then a range. That's an NS range right there, by the way, not a Swift range. And the indexing into these strings is the old style NS string version. It's not this string.index stuff we talked about last time. It's literally which Unicode character are you talking about setting an attribute at. Okay, so this dictionary has a bunch of attributes. The attributes can be things like set the foreground color of this text. Okay, set the stroke width. Okay, because remember, text is just paths. You can stroke them and set the width. Or the font is a really important one to be able to say. Set this text to have this particular font. Okay, and so you just set a dictionary that has the key NSFont attribute, and the value would be a UI font. Okay. Now let's talk about UI fonts briefly. Fonts in iOS 7 and later, including iOS 8, are very important to get right. Okay, look at these screenshots. Look how important the fonts are. Okay, they're critical to making the UI look good. Okay, so you got to get the right fonts in your app. And where do you get the right fonts? Well, the number one place to get a font, the right place 99% of the time, is this class function in UI font called preferred font for text style. Okay? The text style is something like headline or a body. Okay, the body would be like the main content that your user is looking at. Headline might be like a title at the top. Footnote might be a small little thing mentioned at the bottom. Okay, and there's a whole bunch more of these text styles. And so you're going to ask the system, give me the preferred font for that style. The font includes a size. Okay, UI fonts include the size as well as the face. And users can go into their settings on their phone and change and say, oh, I can't see anymore, like me, and they make their fonts bigger, okay? And so this would automatically get that new size. Okay, so that's why you always want to use preferred font anytime you're displaying any user content, okay? Now, it is possible to create fonts where you say, give me Arial 15 narrow, or what. It is possible, but you really shouldn't be doing that. You should be using this preferred font for style. There's also a system font. This is something that appears on buttons and in things like segmented controls, things like that. You never want to use one of these system fonts for user content. User content, you want to use the preferred fonts. Okay? So yeah, other ways to get fonts, ignore them. I'm not going to talk about it. Okay? All right, how about drawing images? How do you do that? Well, there is a UI label for images. It's called UI image view, and you can use that to put an image on screen, but you might want to draw an image in your DrawRect as well. And usually you create an image by name from that images.xc assets thing that we moved out of the way real quick right at the beginning of our very first demo. And if you click on that, it's pretty self-explanatory. You can drag images in. You can have different images of different resolutions for different devices. It's really pretty powerful. That's usually how you create an image, is by name and dragging it into the images.xc assets. You can create it in other ways from the file system, which we haven't talked about, or even with drawing. We're not going to talk about that either. Once you have a UI image, you can draw it by just sending it the message, draw at point. And it will draw in its normal size with that point as its upper left. You can also say draw in rect, and it'll scale to fit that rect, either bigger or smaller. Or even draw as pattern in rect, it'll tile it repeatedly to fill the rect. Okay? So really easy to draw images inside your DrawRect. The last thing I want to talk about is what happens when your bounds changes in your UI view. Like the user rotates the phone, and now your bounds are wide and not very tall instead of tall and not so wide. You might think, oh, my DrawRect's going to get called, and I'm going to redraw. But no, that does not happen. Instead, the bits that were on screen get stretched. Okay? So usually that's not what you want, because that's going to result in a very grainy kind of bit stretching of your UI. But that is the default, is the bit stretching, because it's high performance. Now, you can control what happens to your view when the bounds change with this property in view called content mode. And here are some of the content modes you can set. There's left, right, top, bottom, etc. All these ones basically don't change the bits. They don't redraw, but they just move your entire view to the left edge, right edge, top, or bottom of the new bounds. These are kind of strange ones. Probably don't need that very often. Then there's the scaling of the bits. So here's the default, scale to fill. Okay, we'll scale the bits to fill the new bounds, but you can also fill or fit the bounds and keep the aspect ratio so that it won't stretch your bits. It'll still scale them, but it'll scale them with your aspect ratio maintained. Or you can have the wondrous redraw. Okay, this is the one you want to set that says, when my bounds change, call my DrawRect again. Okay, with the new bounds. So you're going to want that quite often. I'll show you that in the demo today. All right, so let's get right to this demo. Okay, it's going to be a little tight to do this in 20 minutes, but because we're going to cover a lot of stuff, but I think we can do it. We're going to start by creating a new project. So I'm just going to file new project. This is a brand new. Okay, we're going away from the calculator here. And as always, we're going to be using this single view application thing right here. I'm going to call this project happiness because we're going to draw a face, a smiley face. Okay, and it's going to be able to smile or frown depending on how happy it is. Okay, so that's why we're going to call this happiness. I'm going to put